Let us do an experiment to vary the brightness level of LED using potentiometer. Components required to conduct this experiment are potentiometer, LED, one fixed resistor 470 ohm resistor, 9 volts battery, battery cap, one breadboard. In order to check the resistance of potentiometer, we are using multimeter. What is potentiometer and how it works and what are its applications? Let us study first. A potentiometer, it is referred as pot. It is an electronic component. It is used to vary the resistance in an electrical circuit manually. It consists of a resistive element. The potentiometer has a sliding contact known as a wiper. This is wiper. The white part is wiper. The potentiometer has three terminals. Two fixed terminals. They are connected to the resistive element. The fixed terminals are the outermost terminals. This one and this one. These two are outermost terminals. They are fixed terminals. And one movable terminal connected to the wiper. The middle one, it is connected to the wiper. So total it has got three terminals. When wiper is moved along the resistive track, it changes the length of the resistive element between wiper and the two fixed ends. So as a result, the resistance between the wiper and each fixed end varies. This variation in resistance is used to control the flow of current in a circuit. Potentiometers are used to control the volume. For example, they are used in audio equipment such as amplifiers, speakers, radios, etc. to control the volume level. By adjusting the potentiometer, the resistance in the audio circuit is changed. So thereby adjusting the output sound level also changes. It is used in voltage regulation. This is the second application. Potentiometer can be used as voltage regulator by connecting a fixed resistor and a potentiometer in series. So you can create a variable voltage divider. Potentiometers are also used in various sensing and measuring applications. For example, they are used in joystick controls, they are used in robotics, etc. And in lighting system also potentiometers are used. They are used to control the intensity or brightness of the lights. Potentiometers are also used in some electronic devices such as TV, computer monitors, etc. And potentiometers are also used in calibration and testing process. So these are the applications of potentiometer. Now I'll show you how to, by moving the wiper contact, how the resistance varies. That I'll show you. And for this I have to use a multimeter. So I'll keep multimeter position at 2000 because my potentiometer it is 1220. See, so the value of this potentiometer is 1220. It means 1.22 kilo ohm. So this potentiometer I am using. So how the resistance varied? Maximum I should get 1220 ohm here. Now I am measuring the resistance at the two extreme ends of the potentiometer. So how much it is showing in a multimeter? See the multimeter reading. It is showing 1154 ohm because so I have kept my wiper at the minimum position. Now I will move the wiper position in clockwise direction. Now you check the resistance between the first point and the middle point. Okay, so how much it is showing? 199 ohm. So first terminal to central terminal it is showing 199 ohm. See here, now I have kept my wiper at the minimum position. So I'll check the reading between the extreme end first terminal and the center point. So how much reading it is showing? It is showing 8 ohms. Minimum value it is showing because I have not moved the wiper. Now I'll move the wiper. I'm sure rotating in a clockwise direction. So I'll check the resistance now between the middle point and end. So it is showing 187. So again I'll move the wiper. Again I'll check the resistance. Now how much it is showing? 312 ohm. Again I'll move the wiper in a clockwise direction. I'll check the resistance. It is 493. In this way, by moving the wiper, you can change the resistance of the potentiometer. This is one side. If you check on this side, center point and the last terminal, see here it is showing 699. This side it is showing 699. This side it is showing 492. If you add these two, I'll get the total value, that is 11220. So in this way, you can use the potentiometer to vary the resistance. If you are connecting your circuit between these 2 points, it acts as a fixed resistor. It acts as a fixed resistor. If you are connecting between the center point and either this side or that side, it acts as a variable resistor. So in this experiment, so we are using this pot as a variable resistor. So I will use either the first wire and the center one compulsory, or you can use this and this. So I'm using these two because I want to make this pot as a variable resistor. Now we will do the connection. So I want to use 9 volts battery instead of a power supply. So I'll connect the battery cap to the battery. Fix it properly. This is positive of the battery. This is negative of the battery. Connect this to breadboard. So this side I am using this line I am using as a positive supply, and the bottom line I am using as a negative supply. So these two are my power supply, positive supply and a negative supply. Now I'll take the potentiometer. The positive potentiometer I'll connect to one terminal of the breadboard and one end of the breadboard, and the center point of the potentiometer I'll connect it to another point. See here, the center point has come here and the outer terminal has come here. Now from center point, I'll connect one fixed resistor. So this I have taken as a 470 ohm resistor. So 4 is yellow, violet and a black. So it is a 470 ohm resistor. This I'll connect it to center of the potentiometer. See, check here. This is the same point. This all 5 points are same. So I am connecting one end to here, other end to somewhere on the breadboard. This side I am connecting. Okay. Next, LED I'll connect the long lead is anode and short lead is cathode. Anode is connected to resistor, same point resistor, and cathode I will connect it to ground. My second line is ground. Check here, I am connecting to ground. Now I will connect one wire from the potentiometer to your supply, positive supply. Positive supply is here. As soon as I connect, my LED starts glowing. So it is giving us the light. Now I will vary the potentiometer. Now my potentiometer I will start keeping in a minimum position. See. So minimum position this much with this much intensity it is glowing. Now I will move the wiper on the right side. Okay, I have used one more LED to show you. My wiper is in minimum position. So this much intensity, with this much intensity it is glowing. Now I will move the wiper. You check the intensity level. See, now it is almost with a low intensity because I have kept my potentiometer at a higher resistance. So it is giving less brightness. If I reduce the resistance, see the intensity it is giving more brightness. The LED is glowing with more brightness because I have kept at a minimum resistance. If I increase the resistance, the intensity decreases. Okay, in this way, with the help of this potentiometer, you can control the brightness level of the LED. So this is a very useful experiment for electronics students to understand about the potentiometer. Thank you for watching this video. Okay, this is the circuit diagram I have used. Sorry, no, I did not tell about this. This is the circuit diagram. So from battery positive, it is going to pot, the fixed point, and the wiper is connected to 470 ohm fixed resistor. 470 ohm resistor is connected to anode of the LED. Cathode is connected to the negative of power supply. So this circuit I have used. And one more thing you have to understand. So when I increase my resistance, the current flowing in the LED decreases. Because of that, the brightness decreases. So if I reduce the resistance, the current flowing in the LED increases, so the brightness increases. This is only the concept to vary the brightness level of a LED. Thank you.